Hello. Today I'm going to ask you a simple question. Have you ever had a problem in your life that you needed to find a solution for? Were you happy with the result? I'm pretty sure that your answer at least to the first question was yes, and if your answer to the second question was no, today we're here to help you. The process of problem solving could be defined as an activity with a specific goal associated to it that requires the use of several steps or operations to achieve an overall purpose or solution. The whole process usually becomes easier once we have a clear idea and definition of the problem, its initial state, and what the end goal should be. However, not all problems are well defined, and this is why the first basic step when trying to find a solution to a given problem is identifying the specific goal we want to reach. Therefore, we can differentiate between directed thinking, which involves working towards some specific end in mind, and undirected thinking, which is clearly the opposite, like daydreaming or mind wandering. Usually, the second step is identifying the sequence of operations that we are going to put in practice, and this step is clearly followed by the application of cognitive operations. For example, when trying to solve a long mathematical multiplication, of course without the use of your calculator, you need to retrieve the multiplication tables from your memory in order to solve this operation through small steps. And finally, it is very helpful many times to decompose the final goal into several sub-goals and work towards achieving each individual sub-goal. One way we commonly use in problem-solving activities involves the means-end analysis, which could be defined as a heuristic where we are constantly comparing the goal or sub-goal in mind with the initial problem state, and then put in practice specific actions in order to reduce the difference between the two states. For example, if I'm planning to get an A on the final exam for that annoying biology class, I should establish sub-goals such as mini deadlines to have each chapter studied by, reach out to my study group and meet up to go over the material, and of course avoid procrastinating. And then I should put the work in each of those sub-goals in order to get closer to that A.
To solve difficult problems, we utilize a unique form of problem solving called insight. Insight allows us to gain a deeper understanding of the problem so that we can look at it in different ways. We use insight to solve these problems in a way much different than we would with normal problem solving. With some problems, we don't even know we are using insight to help us solve them. For example, when solving the math problem 47 plus 73 minus 73, while it might take you a matter of seconds before you apply insight and get the correct answer, it may take you a while to realize how you got the correct answer so quickly. In some cases, insight might not come to us immediately. This is one of the biggest differences between solving problems using normal methods and insight. When solving problems using a normal method, you work through the problem and get warmer and warmer as you get closer to a solution. However, with insight, you are as cold as you were when you started until the aha moment, when the solution suddenly hits you. It is as if all of a sudden you are able to take a new perspective, overcome your stuck way of thinking, and understand how to achieve your goal. It is much easier to arrive at the insightful answer with the use of an analogy. When you've solved a similar problem before or used similar concepts to solve a different problem, it is easier to reach the solution. This is called using an analogy. However, having an analogy does not always ensure finding the solution. You have to be able to identify that it is a useful analogy and utilize it. The multi-constraint theory explains how we utilize an analogy based on similarity, structure, and goal. If the problems are not similar enough, it is unlikely the analogy will be able to be identified. To use the method from the analogy on the problem at hand, parallels must be drawn between the structures of the solved and unsolved problems. The goal of the unsolved problem dictates how much of the analogy is deemed useful and what parts help to achieve the solution.
Did you know that a lot of the common difficulties in problem solving are a result of useful mental shortcuts that we use every day to save time and effort? One typical obstacle we face in problem solving is called functional fixedness. This is when we are unable to see the full potential of an object's use and get stuck seeing only one function. There's a famous study in psychology by Dunker in 1945 that shows this concept. In the study, participants were presented with a box of thumbtacks, matches, and a candle. They were given the task of mounting a lit candle on the wall. The researchers found that most participants were unaware of the easiest way to solve this problem because of functional fixedness. The best way to solve this problem, if you haven't already thought of it, is to empty the box of tacks and use the box as a mount for the candle. Because of fixedness, however, people are unable to think of the box as anything other than a container for the tacks. Based on these results, you might think that functional fixedness is just an annoying disadvantage that prevents us from solving pretty easy problems like this one. However, it's important to know that thinking behind functional fixedness is useful to us in many aspects of life. This bias arises from our tendency to categorize objects in our brains based on their functions. We do this because most of the time when you want an object, it's because you want to use it. So being able to quickly categorize it by its function is super convenient. The negative effect on problem solving happens because in recognizing an object so quickly by its function, we ignore its alternative uses. Another typical problem solving obstacle is a negative mental set. This is quite similar to functional fixedness, and it's when you approach a problem with only one way to solve it. Mental sets can also be helpful in our daily lives. For example, if you're trying to get through many math problems, you sometimes are able to recognize a pattern of steps that allows you to get the right answer every time. This is one example of using a mental set positively that can save you time. A mental set becomes negative in problem solving when the problem you are faced with requires an original way of thinking to solve it. Overall, both functional fixedness and negative mental set prevent us from being creative problem solvers. But luckily, psychologists have figured out some ways to help us overcome the negative side effects of our daily thinking. Remember that candle task? Well, there's a modified version of the study done by the same researchers. In this version, the participants are presented with the same objects and the same goal, except this time, the researchers took the tasks out of the box and placed them next to the empty box. The success rate for this study was much higher. This is because the empty box was much easier for participants to identify as a potential mount for the candle. This shows you one great way to overcome functional fixedness is to break down objects into their component parts so you can better see their potential alternative uses. Next, we are going to talk to you about some more ways to improve your general problem-solving skills.
For many, problem solving can be frustrating. We've already learned about some of the things that hold us back, such as negative set or functional fixedness. But now it's time to take a look at some of the ways we can make problem solving easier instead. One good way to do this is to increase your domain knowledge or learn the most you can about your topic. This allows for better memory, knowledge, and increased metacognitive awareness, which just means that you get better at recognizing what you do and don't know so that you can focus on what you still need to figure out. Another good way to improve your problem-solving abilities is to automate some components and develop sub-goals. By breaking your big problems into smaller pieces, we can both reduce anxiety as well as make the workload more manageable. Automating components can also reduce the amount of steps it takes to solve your problem. Following a systematic plan is another good way to get better at problem solving. By creating and sticking to a plan, you can track your goals and sub-goals as well as keep your solutions and information organized along the way. You could also change your perspective, which could be done in a number of different ways. You could search for contradictions in order to rule out some possibilities and narrow your approach, look for a familiar analogy, or work backwards. Practicing problem solving can also help with future problems by increasing domain knowledge, reducing anxiety, increasing automation of subroutines, and priming related information. Even just staying calm can help as anxiety can cause the working memory to overload and distract you. Problem solving is more complex than your typical information processing. While it is definitely difficult at times due to natural phenomena we all suffer from, there are always ways to get better. Thank you for tuning in today to learn about problem solving. We hope you enjoyed our presentation.